This off. Oh gosh, no. Hold on, one question we have. Hold on, well, I'm getting here. All right. Yeah, one person I do have to respond to, or else. Yes. Now you got it. So I'll just put it over. I have it on unbuzz, and I'll just tell her in lab, and she'll be fine. So I've done something really wrong, which is very possible. Moving on. So we'll look at the muscles here, and I'll just and basically I used to do labeling the muscle. It's so hard with these models to get anything really right. So I'll show you what it is when we take a look. This is the only one we haven't done, and again, it's the major muscles that concern us in this particular unit. And I do have the practicals here. That was a good question I was asked before. There are 30 possible points. Most people did really well. Okay, so at the end you can come up and just figure out who you are. It's based on a minus number wrong versus number right. So like if it was, let's say somebody got, I have half credit. Let's say somebody got 10 and a half points deducted. Then I made that 10 rather than making it 11. It's kind of like the opposite as you might have in a lecture class where maybe you had a 78.5 and they made it a 79. So, you're rounding down for you're rounding in the direction that assists you, if you want to. And the scale was fairly, typically the scale I used. We had some people got close to all of them right. So most of the scores range probably between, have 30 possible points, between 24 to 30. So if you look at it as 100 possible points in the lab, so you're going to see, anything that you've been here, the quizzes, 30 points each of the major grades that are there, all that stuff. Add all that stuff together, it's 100 possible points. So you look at how many points you might have lost. So if the quiz you got 14 out of 15, you lost a point. If you got 27 out of 30, you lost 3. Now you lost 4 points. So, I mean, you still got, probably if you've got something within, if you lose 10 points or less, you're probably still getting an 8 in the quiz. Okay. Like I said, in the lab, you have to work particularly hard not to get an A or a B. You have to really exert yourself by not doing anything and not showing up, which is not something that people don't necessarily. Some people are able to do that with some degree of alacrity, but I digress. All right, so that's the laboratory stuff. On to these are mostly the lower extremity muscles that are there. The good news about these, they're larger, they're grouped fairly easily. Okay, and again, it's interesting. At torso to the hip in the front, they flex, bringing your thigh up on your torso. Posteriorly, they extend, so it's like standing up. You're bringing your thigh away, so to speak, from your torso, or flexing will be like this. So for forward swinging and backward swinging. And you can see that there's different groups of muscles that are there. Muscles on the interior are adductors. They tend to pull it together. And there's some that abduct as well, but there's a lot of combinations. But they're kind of large, and really it's the major ones. This is a monstrously, and it's one you really don't see. Okay? In the anterior aspect, this one is really inside the pelvic rim. It's called the iliopsoas. It's actually two muscles wrapped in one. The iliacus, which is inside of the iliac, sort of the pelvic crest area in the interior of the ilium bone. And the psoas major, which is kind of a long, rounded, then somewhat slender muscle. And they come together and they pass through the obturator foramen and they insert or attach onto the lesser trochanter. They're powerful. So, and it's funny, with muscles, the best analogy for muscles is meat for all you carnivorous or omnivorous people. So when you talk about the tenderloin, that's what the psoas major is basically. If you're getting filet mignon, and I hope you are, that's the psoas major. So it's a unique kind of interesting muscle. So if you go to the store, you can see them, and then basically we cut across to make small steaks like that. Help me. They're called medallions when you do. You guys got to watch more cooking shows. Tensor fascia lata, the muscles in your thigh. You got a big bunch in them, but they're basically anterior, posterior, and medial. The fascia lata is the big, thick connective tissue that holds them to the bone. And you got to have a band around everything will both string out every time you use them. So the fascia lata, and there's even a muscle that helps you tense it, goes all the way down this way. There's a lot of really, in sport, we have a lot of injuries that occur along the outside. There's a band of tissue, some of that aponeurosis, that gray stuff that's there. It's called the iliotibial band. It goes from here down to your tibia, and that's another anchor point. And a lot of athletes will get that. It's called iliotibial band syndrome. So there's a lot of muscularity. You can imagine that force that's in that area. So the iliopsoas, I have no idea what that is, why. I hope you're good at something. Okay. So the iliopsoas is the one that basically does this. Tensor fascia lata just helps to bind the muscles, so it sort of helps the muscles work. Rectus femoris, there's 4 muscles in the front. They're called quadriceps femoris. The rectus femoris is centered straight. You have 2 broad muscles on either side that are so big we call them vas. Vastus medialis and vastus lateralis. And underneath it, there's one in between them that's underneath the rectus femoris called vastus intermedius. That's the one when you do straight leg raises for knee rehabilitation. That is inserts into the knee joint and helps to strengthen. So there's a lot of science behind particularly the rehabilitative aspect. And then you have the adductors. And what you're going to see, there's many of them. The biggest one's called adductor magnus. This is enormous. You have adductor longus, adductor brevis. Sartorius, I mentioned a little bit before, it's a strap-like muscle from the anterior iliac spine that goes in front, so it flexes thigh upon the torso, and all the way down to here, so it actually flexes the knee, flexes the leg upon the thigh. That's the one I was telling you about, the Taylor's muscle. Taylors used to say that their legs would be really quick. In the days before we had sewing machines. And then, so you have the adductor group, the anterior group, and the massive sets of muscles called hamstrings. The hamstrings are just that. They make ham from the muscle portion, which is higher up, the upper thigh portion, is where they make ham from that. And that's basic. What can I tell you? Cooking shows. Prosciutto di Parma, which is uncooked. Prosciutto crudo, as it's known, uncooked. Sorry, having food moment. So I have to show them to you. It's easier, like this. So here you can see this is the iliacus. You can see the cursor. Here's the psoas major, and they kind of come together, and you don't see it necessarily. It's going all the way into the lesser trochanter. Sartorius, this strap that goes from the anterior superior iliac spine all the way behind, and there's a couple of other tendons that sort of are in this area. This is the rectus femoris. This is vastus lateralis. For nurses, that's important. We give a lot of injections in the thigh. It's a big, broad muscle. Vastus medialis is on the other side. Now you can begin to see, and these are also good size. These are part of the groin muscle called pectineus. It comes basically from the ischiopubic area, adductor longus. This is the most medial muscle, and it was such an attractive muscle that anatomists, they said, oh, it's just this fine-looking but strong muscle, very graceful, so they named it the gracilis. So sometimes the names had to do with, these are anatomists 500 years ago. maybe 700 years ago. So it was basically during the Renaissance period when a lot of these names sort of took place that were there. And so all four of these, the rectus femoris and the three vasti, this is called the quadriceps tendon. You'll hear about athletes rupturing a quadriceps tendon, a really nasty injury. I would participate in a couple of these operations. It's usually right here. The structural weak point, when you hear about an Achilles tendon, like happened to Aaron Rodgers relatively recently, and it just happened to the guy from Minnesota, whoever he was. That we call that the myotendinous junction. That's the structural weak point where muscle and tendon come together. And so orthopedists and people who do orthopedic procedures, familiar. So that's a quadriceps tear. You sew that back together. And the quadriceps tendon envelops the patella, and this is called, as everybody knows, the patellar ligament. That's the one that inserts into the tibial tuberosity, the bump in front of your tibia, and that's where you test the knee jerk. There they can show you that's iliopsoas, what it looks like. So it's a really foodie perspective. It doesn't move. There's not a lot of thick connective tissue. That's why it's a textural component for foods, if you're wondering. Sartorius, very long, longest of all the muscles. It's a good little factoid to remember. The adductors, as you can see, there's many. Magnus, giant. Longest, long, brevis, short, pectineus, and gracilis. That's the medial group. So they basically attach around that obturator foramen. So the obturator nerve, when you get to the naming the nerves, which we do more in AP2. Some of you inquired, and I appreciate the inquiry that if I was doing an AP2 lab, I was, but I'm not. Because we needed some. We had one of our professors was supposed to teach micro, was unable to be on campus this semester. It was a family-related stuff, as much as I know about it. And so we needed to cover her classes in her labs. She was going to do all the micro, or a great deal of the micro. So I usually get a micro, and I have 2 micro lectures, which means a lot of us are very busy covering. And please don't take me because I don't like anybody. That's right. So if I recognize any of you, I'll know you weren't listening to me. I saw some of you have registered, which makes me upset. Joking. Oh, you're all awful. And you can read all this stuff. Okay, so here they are. The neat thing about this guy, the adductor magnus, there's an opening. Now, what is that for? That's called the adductor hiatus. So I said, they're all around the obturator foramen. When you hear about somebody pulling a groin muscle, this is what they talk about. They hurt like crazy. You go to any gym, they have all those machines where you can, push them in and work them. My wife loves to work on those. When we go work the machines, that's called the adductor hiatus. Interestingly, the giant artery that services your lower extremity, called the femoral artery, you'll learn about next term, goes through this and goes from the front to the back, behind your knee. It becomes the popliteal artery. It's a unique area for an artery to start in front and go back. It's kind of interesting. So you'll see that down the road. They'll show you some pictures. Quadriceps is the name for all 4 of those muscles. Rectus femoris and the 3 vasti. Very powerful. They're showing the same illustration again. This is now you're just watching the intermedius, the one that's inserts right into the knee joint, the lateralis, and it doesn't do it justice. 2-dimensional. In medical school, you dissect cadaver to learn about them. Some of these muscles are unbelievably big. I mean, extraordinarily large. You sort of look at it and wonder how large they are. And and basically they've all flattened out because obviously it's a dead person. So, I mean, you get a better idea of the size here than there. So I thought that would be of interest to you. And you may get an opportunity to see, we don't have a cadaver here. Only one of the schools I've ever taught at, 2 had cadavers, and they were pretty well reserved. Though thankfully, when I was teaching at Chatham for about 5 years, they got a cadaver toward the end of my tenure there, and there was for the professor who was teaching graduate, but he always invited the undergraduate students and the nursing students who were for Shayside School of Nursing to see it. This is that tensor fascia lata. So think of that as a helper muscle, because when you tense it, it holds the muscles close to the bone, gives them more power. That's the idea of what muscles working synergistically, working together. And that's important. Now, posteriorly, you have the three gluteal muscles. They're the ones of significance. You're sitting on it. Your rear end is your gluteus maximus. Higher up on the hip, an extraordinarily common site for injections in nursing is the gluteus medius. And medius basically is the one that kind of helps you lift up your leg that way. Okay, the maximus is really the primary extender. It's one of the things for us walking upright that has developed over time. Most four-legged animals don't have, if they have any, it's very underdeveloped. So it's really the muscle that kind of allowed us to become upright. But so the way you test for the medius, and there's, is basically have somebody stand on one leg and lift their other leg up. And as long as you're able to do that, it's intact. And the minimus doesn't do a whole lot with regard to that. So you see there, you can see the gluteus maximus. So the medius is up here. It's more on the hip than, let's say, part of the buttocks, if you want to think of it that way. And see, this is the medius. And the minimus is underneath it, and it's vestigial. Here's the maximus. Again, long tendons that tend to continue to insert, and these are the hamstrings. What you have to do is feel behind your knee, those big leaders that we call them, those are the tendons. And on the exterior, you have a two-headed tendon called biceps femoris. I mean, we have a biceps brachii. So I'll understand. And I'm pretty forgiving about that. Not everybody is. But in a nursing class, and understand nursing instructors eat their young. It's true. Okay? I always say that. I'm not telling tales at school. I'm sure they say, Dr. Stein said you eat your young. Okay? And they're your toughest critics for you going into nursing. It's always, who's ever in your profession gives you the hardest time, trust me. So if you say, oh, that's the biceps, and you're pointing to this hamstring on the outside, that would be incorrect. Biceps femoris, because there's a biceps brachii. So it's got two names, you got to use it. Then you have semimembranosus, which is more on the outside, so you can see where it's going, and semitendinosus, and it's just that. When you look at these muscles, the tendinosis has like little strips of tendon that all come together. It looks like half muscle, half tendon, semitendinosus. And semimembranosus, it's almost, you can stretch it out and see pieces of membrane between the pieces of muscle. That's how they got their names. So and they are all powerful. They all are powered by the big sciatic nerve. They basically create the upper outline of this diamond-shaped area we call the popliteal fossa, the area behind your knee. It's there, and they're just showing them to you a little bit more. So you can see membranosus has got a little more like soft tissue in between it. Tendinosus is more tendon, and the biceps deeper in here, without going into all the ins and outs of what it's like. The medius is pretty big. These guys are inserting more on the external portion, more greater trochanter area, on the humerus. And if you strip it away, you can look underneath. And then these are a lot of muscles that sort of can stabilize and support the hip joint. Okay, so the hamstrings are the posterior thigh. They work on both the hip and the knee, so they extend the thigh but flex the knee. And you see hamstring pulls all the time in sport. All the time. They're a typical injury when somebody's lunging, like lunging to make a catch, trying to catch somebody running away, and they'll just all of a sudden they'll grab back there because they'll feel it go, and it's like you're done for a while. And so again, that same illustration they used, same illustration before. Better look. Biceps femoris. So you have one that comes from the femur and one that you can see coming here from around the ischial area. So a longer head and a shorter head, and the tendons are there. And, pardon me. So semimembranosus is a little thicker, more external, and semitendinosus. So membranosus is here, biceps femoris is here, this one's in the middle. We're almost done with these muscles, thankfully. And so we have leg fascia as well. That's there. So the fancy name, we call it the crural, C-R-U-R-A-L. It's a term you may or may not hear from other people. But it divides it, just like we had 3 compartments in the thigh, we have 3 in the leg. Leg's a little different because you have shin. Okay. So with the shin, you have bone here. So you have muscles here, like anterolateral. They're the ones that help you put your toes in. So they're mostly extensors of the foot. And you have muscles along the side that sort of stabilize the exterior of the foot. And we have different names here called perineus. It sounds like perineum. So now they call them fibularis muscles because they're arise from the fibula and go around the lateral malleolus. So you have a lateral or fibular group, an anterolateral group, and here, big plants. Okay, you have your calf muscles. Calf muscles, you're going to name it called gastrocnemius. There's 2 heads, medial and lateral, on the femoral condyles, and underneath it, a monster called the soleus. And together, those muscles, the 2 heads of the gastrocnemius and soleus, come together and famously form the underneath them and behind the medial malleolus, you have 3 muscles we call Tom, Dick, and Harry. Because they are the ones that help you, like, not bring your toes to your nose, but next step on the gas. Flex your toes. You're doing something like that when you're walking in the sand. And so one is called posterior tibial, kind of stabilizes your foot on the inside. One is flexor hallucis longus, Alex the big toe, pulls it down. The other one's called flexor digitorum longus. So Tom, Dick, and Harry is posterior tibial for the T. D is for digitorum and H for the Alex. That's how we remember. You're not going to have to remember, but I'm trying to give you, those are like the little tricks that you learn because those are easy to remember. Tom, Dick, and Harry was a movie from 1941 with Ginger Rogers and Burgess Meredith. Nobody has heard of any of these people, have they? Not a one. 4-star movies of dance with Fred Astaire and Ginger Rogers. They were the best dancers, ballroom type dancers you ever saw. And then Burgess Meredith, everybody see Rocky? Very famous movie. He, in the first Rocky, he plays the trainer, the gruff old guy. You know, that was the late Burgess Meredith. Just brilliant. Brilliant. So, moving on. Hello. Here they are. These are the anterior lateral group. Tibialis anterior, sort of stabilized, pulls your foot up on the inside. Extensor digitorum, extend your toes. And then, and this one's not there, it's not a big deal. An extensor hallucis. And I've operated on all of these. Okay. And so here they are. So they're right along next to the bone. And a very famous problem that people get is called shin splits. And it usually has to do because their foot's unstable and their legs compensating for it. And it's actually, the muscles are being pulled away from the bone and it hurts unbelievably. And sometimes it swells so much you get something called a compartment syndrome because of the tissue around it. Okay, it doesn't, the swelling can't go anywhere and it can paralyze the leg. So there's what to know about with this. Not that you have to know it, but depending on where you're going, you might. So we have, these are called retinacula. Retinacula are connective tissue fibers that are not as thick as ligaments, but close, and they bind tendons. Tendons on around here. Remember the one in the shoulder, the biceps tendon? They have a tendency to motion. So one of the things that's happened, they rupture, all of a sudden you'll see one of the tendons that they pop out. You actually have to push it back in and then oversew the retinacula to do that. Tendons are under a lot of tension. And in surgery, we have to simulate a person to sleep. anesthetized. State. So you have to try to imagine what it would be like at rest, because even at rest, there's tension. When someone's completely comatose, you use it. Most of the time, you lose somebody else. One of the ways it makes sense. So when you operate, you don't want to make it too tight or too loose because you would actually constantly, like this, like that. It's embarrassing. And they have sheaths, and you have to make sure that they stay in the sheaths because of the tension. A lot of times it'll be like, it's like you're pulling a cord with lines. You know what I mean? When it goes right up, like boom, that happens. You learn early on when you're operating on tendons to tag, put a piece of suture material with a clamp or a hemostat on it, so it doesn't bowstring, it doesn't snap up. Yes. Long time ago, galaxy far away. Nothing for the last 23 years. So here's the one that goes to the inside of your foot, helps to hold it up. Big toe, hallucis longus, the fibularis tertius, a helper, extensor, and you'll notice most of the arrangement, you have something that goes to the big toe or to the thumb, and something that goes to the rest of the fingers or the rest of the toes. And that's a consistent pattern. On the outside, you have two. They're really super important. These are big stabilizers that go around the lateral malleolus. One goes all the way across your foot to here, and another one inserts into that. This is the fifth metatarsal. So that tendon, you can literally pull the tip of that bone off, and it happens with some degree of frequency. It's called a Sir Robert Jones fracture. So I'm watching here. I'm a Manchester United supporter. My kids won't watch the Steeler game with me. They gave me one of those bricks that was made out of foam because I throw it when the ref made a bad call. I'm one of those. I'm going to have Fletcher. That sounds like your house. See? I'm crazy. They're like, the dog looks at me and go, he's freaking nuts. Moving on. So, on my team, the guy who was a World Cup winner, Sandro Martinez, he popped that bone off innocuously. Like his toe got caught, his foot bent down like this, and you pull that bone. You have to operate. You have to put a screw in that and put it back. Very nasty fracture. Called the Sir Robert Jones fracture. Moving on. And here it is, right down in there. You see where it goes? Where I'm pointing with the cursor? Right into that. This other one goes all the way across like a stabilizer across the bottom of your foot. And then the big muscles, that's the fibularis, and the fibularis brevis are short. And here they are, the calf muscles. Medial and lateral heads of the gastrocnemius, and underneath them is the soleus. It's monstrous. The fibers come together and insert into the calcaneus posteriorly, the very famous tendoachilles. This is the soleus underneath it. It is unbelievably strong. Massive muscles. And then you have those deeper flexors behind it that go to the bottom of the foot and the big toes, etc. And that's everything. So, I wanted to show them to you. If I asked you to label a picture, it'll be trapezius, it'll be latissimus dorsi, it'll be gluteus maximus. It'll be a big muscle that you can't miss. Okay? I think that's all we do not need to go crazy with this. And it's not that I don't think you could learn all the intricacies. You have enough on your plate, I think, comparatively speaking, particularly preparing for finals week for most of you in your first year. That's just my 2 cents about it. Which brings us to this. And I'm not going to really use the PowerPoint to tell you about it. This is what you're getting to. The way I do, when I do AP1, and I've done this, the first year I've done is basically end with the stuff you're doing now with neuroglia, all that stuff, astrocytes, oh, and all the things, Schwann cells, and all that good stuff, and all those reconducting things. You love those.
Yeah.
What? Okay, it's okay, it's okay. I have fun with it. So basically, understand what you are. Okay, your central nervous system develops, and this is what we talk about anatomically. You're going to cover a lot of what it does. What the cerebellum does, what the frontal lobes do, etc. But really what it is, it's a neural tube. What makes a vertebrate, maybe you had this in high school biology, three things. Pharyngeal pouches, which basically which is really your acoustic tube or pharyngeal tympanic tube, eustachian tube, where you get ear infections. That's a remedy for that. You have something called a notochord. The notochord really makes up the center. We covered this in the vertebral canal and the discs. It's like that gooey, soft instrument. And then you have what's called a dorsal hollow nerve cord. That's your nervous system. So it's basically hollow and filled with fluid, cerebrospinal fluid. And the nerve stuff is all around. And effectively, what happens is we grow. It bends, it twists, it turns, it widens, it narrows, still filled with cerebrospinal fluid, and your brain develops around it. That's the nervous system, basically. And you'll see the pictures are very persuasive to understand what they look like. And understand I have a lot of personal context for this that, and I share it with everybody now. I was a little reluctant a few years ago. Every so often I show you pictures of my little granddaughter. She was born and effectively suffered a pediatric stroke when she was born. Okay. She's doing fabulously, wonderfully, brilliantly. We are ecstatic. She's never going to walk completely right. She's never going to have full control of her right arm. Okay. We didn't even know about it for the first 6 months. That's how. So effectively, her diagnosis is consistent with cerebral palsy. And people have a misunderstanding about that because they associate it with the R word, retardation. I know you're supposed to say it. But mental impairment, which is not true for cerebral palsy. And thankfully, but she had one side of her brain that hardly developed at all. Yet she is, talk about talking. And I make no mistake, they told my son and daughter-in-law that you will be lucky if she can walk and talk. Watch out now. Yeah. And it's just to give you some context. So let me show you. So I take it very seriously, and it's just, we are blessed that she is doing as well as she is doing. This is the idea of what's called cephalization, the development of the brain. And they'll go through it, and I'm not going to hold you to these terms and stuff like that. You're going to have to know about the midbrain and some of the parts of the brain. But all this stuff I usually do for a lecture. But I wanted to show it to you. That's what I was holding up. The blue would be cerebrospinal fluid. The brownish color is effectively what's going to be your brain. What happens over time, it widens, it narrows, and it begins, because it's enlarging so fast, it has to kind of fold over on itself, because there's not a whole lot of room up there. It's growing faster than the bones of the skull. And so it's this consistent pattern anatomically of folding over. Look, we can fold that thing up. It's like accordion flutes. You see it everywhere. You'll see it in the heart. You've already seen it in other areas anatomically. It's all about surface area. You talk about villi and microvilli and cellular appendages. Yes? You'll see it. Okay? All of those things are there. In the brain, those folds have names. They're called sulci for indentations and gyri for the mounds that you see on a classic brain. So that's what you're seeing the development of. And then all of these have interesting names, and so the brain grows faster than what's around it. And so it begins to bend and shape itself. So take a look. week 5, gestation. You're starting to see this tube widen. Some of these areas here and here are starting to become more elaborate neurologically. They're starting to form more brain stuff. End of the first trimester. That looks like a brain. Okay? The large part, the frontal lobe, the start of the optic nerves for your eyes. But more than half of our neural circuits are dedicated to vision. This is called the thalamus, a giant relay center. That's the start of the pituitary. This is the midbrain, which kind of stays the same a lot. This is called the cerebellum. It's the second largest area. It's behind here. And really, it's every time you move, it's collecting a pattern. And it remembers those patterns. So when you move, you don't have to think about it a whole lot. Think of it like it's muscle memory. Like, I don't know about you, unless you're different than I am. But when I'm done with here, I'm walking back to my office. I don't go, okay, Lou, lift up your left leg and put your foot forward. Shift your weight. Now do that with your right. Do you do that? No, you get up and start. Muscle memory. Well, and you know what muscles to move, what part what to do with your toes. All the muscles are coordinated. I'm crazy. I was grading your papers at like 5:30 this morning. Don't even go. Well, I was up at 4. Last night we were probably in bed about 11 o'clock. I only have 4 or 5 hours better like this. What? No, I'm not. Many years ago, a buddy of mine in high school said, you know, if you sleep 8 hours every night, you're sleeping a third of your life away. It always stuck with me. It's like, I'm too interested in stuff going on. It's just who I am. What? Oh, we're 2-0. What? We're up to Manchester United's up 2-0. 2-0, as we used to say in my old neighborhood. Nil. It's British. Here is at birth. These are sulci, the indentations, gyri, the mounds, all folded. What do we do to conserve space? We fold. Look at your gut over there. Your intestines, 30 feet of intestine, folded so they can fit inside your gut. What mine they have. Self-deprecating. I am positive I get too much body. As I keep telling her what my wife said, get in shape, and I look at her no rounds. She goes, get your posterior hip. Yes. You go? Yes. Not as often as I should. How often? Yeah, you should go. For me, for cardio, you should do that. 4 or 5 times. No, thank you. I've seen that movie. Not for me. I haven't had that for a while. My son deployed at 1 o'clock. My son and his destroyer left Norfolk at 1 o'clock. Going east, leave you go. So that was 5 months after they got back from a nearly 1-year deployment, given all the stuff that's going on. So that means no Thanksgiving, no Christmas with the kiddies. So the ROTC thing, that's what he did. So how many days do you PT? 3 days. The Marines, in the Navy ROTC unit, his roommate was one of the Marine graduates from ROTC, 7 days a week PT. Well, if you don't pass the PT test, then you Biol, and they give you every day. Every day, and for the Navy ROTC there, back he was matriculated Duquesne in 01, graduated in 05, 6 days a week. Okay. They're running around. He loved it. It's fun. Well, mostly because he liked running around because all the girls would sit and watch those guys like between 6 and 8 in the morning on the pit camp. Don't ask me why he thought that was interesting. He's one of those. We went through a lot of girlfriends. His wife is so nice and wonderful with the kids. If they, heaven forbid, they would ever separate, we will take her. We want her. Moving on. So that's your brain at birth. It's very much the human brain. There's not a whole lot of changes. So I mean, I know I'm taking a little extra time, but I want to show you my construct. Before we look at all this, and this is something I'll talk to you about next time in lecture, because there's a couple of things we do have to go over. I always do the cranial nerves, and I'll save that for next time or right before we do the dissection. But the consistent pattern you're going to see is that we have cerebrospinal fluid both in the middle and on the outside, though it's not depicted here. We have gray matter, and then we surround it by white matter. When you see the term cortex, like cerebral cortex, up here, it'll be different. This is the brain stem. You have a larger opening for cerebrospinal fluid. You have gray matter still around the area where the fluid is, but you have additional what we call islands of gray matter. Those are for nerves that are doing more things, making your organs work the way they're supposed to, allowing you to swallow and speak, that type of stuff. Okay, and lastly, this is the cerebral cortex, the highest order processing. Now, those fluid-filled areas have changed shape very uniquely, and not only do you have gray matter around them, you have gray matter called cortex. Cortex is gray matter, and that's where you do the heavy-duty thinking, processing visual, auditory information, solving problems, taking a test, communicating, all that comes from there. What you're learning about, you learned about ependymal cells, neuroglia that line, and they help to create, they don't create so much as they finalize cerebrospinal fluid. And they have little tentacle-like projections, little cilia that kind of move it around. So they create basically a current that's there. The ventricles look like this. That hollow tube I showed you has grown into, it's all the same tube. It's grown into these big C-like structures that communicate with each other. It's grown into another one that's circular around the middle. It's grown into another one that's big in the back, and one that goes all the way down the spinal cord. So it's really interesting, and I'll go over all of these next time we're together, and go over the parts that you do need to know. And then you have these gyri or ridges and sulci. So let me give you the construct while I'm here. I write this on the board. I have a picture of it elsewhere in my files that I'll send to you guys, because my handwriting is atrocious. Thank you. Already concerned. Pardon me. So many buttons. Okay, it's like a batting order. The highest order functioning is up here. That's the cerebral lobes, cerebral, and we would call it, or you can say, cerebral cortex. You have 1, 2, 3, 4 lobes that do stuff. The frontal lobe, remember all those bones, they're made for the bones. Frontal lobe, math, language, logic, processing information, deciding on what to do. Look at a test question, what am I going to do? So, and very much motor activity. So it's directing you to do stuff. Parietal, sensory. So whether you feel it's warm or cold in there, maybe the chairs, which are annoying, I wish there would be other ones, start to feel really uncomfortable or should position. Really simple. Okay? Occipital, same for the bone. Visual processing. All that you're seeing, before you even react to it and interpret it, is bringing material in, it's creating the image, it's right then it starts shuttling the signal forward and backward to associate with other things, so you can tell if there's a letter O. So, you know, that's obvious, but that's technically what it is. And then the same thing auditorily, temporal lobe has a lot to do with sound processing. That's a very quick overview, because I don't want to keep you overly long this stuff. Just wait for Mike. Just 2 seconds.
Oh.
Yeah. We can see who registers. We can't turn you away.
Oh. Are you excited to see me?
No.
Oh, okay.
I can't, I'm just sick. I'm gonna have to take my after. I may have to have more than one, I may have to have 2. We don't, my wife and I don't. Okay, underneath that, you have something called, that's really part of the same area, it's called the basal nuclei. They're really important. They're part of this assembly up here, but they're inside. So when I say reach for something, you don't give a second look, one look. But think of it when it's like starting, stopping, do I have to go hard, do a little bit. Read them and give it a second look. It's like fine tuning your motor. So think of it as motor fine tuning it. Because this is more like move this, move that. This is how fast, how slow, when, where. It's affected by a disease you've all heard about called Parkinson's. Typically, the Parkinson's has a lot of things that cause it: trauma, maybe medication, tumors, infections. When you see Parkinson's-like symptoms, you typically are sensitive in the basal nucleus. Next area, this is called the diencephalon. Got a lot of major structures in it. Okay, it's got, and this is conscious up here. Here you have control. Once you start getting here, there's a certain degree of awareness, but it's more of your subconscious. The processing goes on. It consists of a very large structure, even though compared to these other areas, called the thalamus. We always say thalamus, spelled Thalamus. That is effectively a relay center. Every sensory signal that you get, when you reach out and touch this, what tells you this is a flat tabletop without looking. Your thalamus is taking that information and sending it to the appropriate part of your brain. You also pre-process it, plays a role in other things you're connected to. Underneath it is an in-between layer called the hypo, which means below the thalamus. And that is the link between your nervous system and a system you're going to learn about next time called the endocrine system. So when you're driving a car, some idiot cuts you off. And other than all those things that I have a tendency to say that I will not repeat here, creative use of the F word. God, why the F word? What happens there? You pull the car. Maybe you pull the car. Maybe you almost got an accident. Think what's going on with you. Your heart's racing. You're breathing fast. You're sweating. Somebody would walk in the room and say, "What the heck happened?" No, some idiot going on the cliff. That's your endocrine system, prolonging that activity. So that's the link between the two of them. Very, very pivotal area. It's the area where you learn about it if you didn't already call the blood-brain barrier. It's where we sense, do I need more sugar? Do I have too much sugar? Do I need more salt? Do I have too much salt? You'll be able to, there's a lot of little sensors there that detect chemical presences. Hypothalamus. There's a little guy behind it called the epi, which is like outside of it. It's actually a gland also endocrine, called the pineal. You'll see it on the dissection, it's like a pineal. And we're not really sure what it does. It has something to do with body rhythms. So you asked me about sleep, but you have your own, somebody has their own sleep cycle. If you go to bed at midnight, you get a name. A lot of people don't feel like it. Or if you have somebody, my wife is a 3 to 11 person. She works as a nurse 3 to 11, most of her work. So I'm asleep by midnight. She's up reading, watching videos, doing stuff around the house. Okay. But I can't sleep, and she's more used to 3 to 11. What about somebody works 11 to 7? Kind of time turns around. So it has a lot to do with, you have rhythms in your body that release certain chemicals. We adapt, and you adapt to it, depending on what schedule you work, what you do for a living, all that stuff. Yeah. I never thought my kids would get up early, but they do. They say, oh my gosh, I can work it. And my middle one works on Neville Island. You know, and I have to probably leave this house over 5 o'clock, over, put her at 5 in the morning. It's always there. I never thought you would that. And around this, a very unique system that plays with your emotions called the limbic system. The limbic system is a little harder to discuss without me showing it to you. There's a lot of things that play into it. A lot of things we do are clouded by, it's like the guy cutting you off. You know, all of a sudden, you try to run somebody down, you want to pull them over and start a fight with them, and it comes out, the person looks like they're 3 people at once, almost. I don't want to do this. But sometimes we respond emotionally before we watch it. So there's a fine line between, and some people, it's like road rage. Okay? People have anger management. Everybody's a little bit different. And that's what those are tough areas to control. So we all have that. Not all of us keep our emotions. Some are too emotional, and some are really not. So that's an interesting area. So now, at this point, anything after this, we don't really control at all. So that will come from an area collectively we call the brain stem. There's a lot of important stuff there because it's regulating all the stuff we don't control. Breathing, blood pressure, heart rate, circulation. The things that allow us to do business without thinking about it. And there are different areas. The midbrain, relatively small, pretty much the same from when we started with it. An area called the pons, and then an area called the medulla oblongata, and they get progressively small. Medulla oblongata, it's an oblong piece of tissue. And those all do sort of these basic functions. The good news is it's relatively small. We're talking about a couple of inches down here. Like that is roughly the area of your brainstem. Right about. The bad news is if it's damaged, those are things that people end up in comas. That's the kind of stuff where they no longer can regulate heart rate and blood pressure. If there's a tumor there, it's a big problem. And we'll get into it when we talk about cranial nerves. That's how you get to interpret whether or not there may be any problem. So that now behind that area, there's an opening there for cerebrospinal fluid. We have the cerebellum. And that cerebellum I was talking about, the second largest area, it's got a great word. Ipsilateral. Most of the time your body works contralaterally. If I want to move my right hand, the left side of my brain. If I feel something with my left hand, my right side of my brain. That's contralateral, opposite side. Ipsilateral, same something. So this is ipsilateral motor coordination. It's like, so when I'm doing this, despite my terrible handwriting, it's not just me taking and holding the marker this way, moving my arm up and down, but I have the other muscles on the same side that have to do the same things, that walk from here to there or sitting down. I don't have to think about it, but I have the memory of what muscles, and this is, each side has kind of its own concept. It's lateral motor. See, we learn something new every day. And lastly, which we have absolutely nothing higher function, That's more or less just signals going in and out. Underneath that is spinal cord. And the spinal cord is just outgoing and incoming signals, reflexes and things like that. Nothing really higher order, no special functions. Just big trouble if it's not working right. Remember, we're all complete with answers. I mean, with examples. You know, the Steelers have been looking ever since a guy named Brian Shazier tackled the guy the wrong way and ended up with kind of spinal shock. And I use N. We ever play again? It's obvious. You can walk again, you can do everything, lessons, you can wonderful guy. But, you know, that's clear. That's my construct, everybody. And like I said, I have a picture with a little bit more information for you that you can use. And I'm happy to share it with you, and I'll send it to you separately. So, and that's what I really have to share with you today. If you want to see, and most people, you can keep these, I don't mind. Everybody took them except one person, and I've gotten in touch with him, but he hasn't gotten in touch with me. He has, but he hasn't made arrangements to take it, so and I'll change it anyway. So we're all good other than that. So this is one of the few times I can get to know your names. It takes me 2 years to learn names. I